Hello, welcome to our Caise2020 tutorial where we will introduce you to the 4CID model for teaching complex learning subjects in information systems. I am Monique Snoek and I co-developed this tutorial with Daya Bogdanova. We welcome you on June the 10th, and in this video we will give you a sneak preview on what the tutorial has to offer. This tutorial is about teaching, but what is teaching about? Most of the teachers start thinking about the content they want to offer in their course. They also reflect about the exams and the kind of questions they are going to use to assess the learning of their students. They might think about exercises or cases to train their students to have better results at the exam. And then usually the institution also asks you to make the learning goals explicit. But all these components have to be coordinated with each other. And that's not an easy task, especially not in complex learning. One way to organize your learning goals is to base them on Bloom's taxonomy that identifies cognitive levels and knowledge dimensions. So the most basic cognitive level is about remembering things. So for example, remembering all the symbols that you have in the BPMN modeling language. One step up is about understanding the meaning, for example, of those symbols. And then in the third step, it is about applying what you have learned. So for example, choosing the right symbol to represent a given activity or a given type of event. Analyzing is a more complex cognitive level, where you will investigate, for example, how an artifact has been built. So for example, analyze a piece of software to see how it has been organized. A higher level is to evaluate things. So for example, comparing two designs to see which one of the two designs is the best one in a given situation. And then finally, the most complex cognitive level is about creating things. For example, creating an information system. The different knowledge dimensions identify different types of knowledge. Factual knowledge are things like, for example, knowing what the letters UML stand for, or knowing all the symbols of BPMN. Conceptual knowledge is about concepts like what is a compiler, what is a process, what is a class, what is a database, what are requirements. Procedural knowledge is about how you need to do things. So for example, how do you compile a program and create an executable? And finally, metacognitive knowledge is about knowing where you are as a learner and how you learn and what you know and what you don't know. While Bloom's taxonomy is very useful, it also has certain limitations. Consider, for example, the following task. Make a list of candidate classes from the given text according to the class elicitation guidelines. This means you have to know about elicitation guidelines. You have to remember them. You have to understand them. And of course, you have to apply them in this case. But by the fact that you apply them, you also create things. You create classes. So very often, a particular task cannot be uniquely classified in Bloom's taxonomy. In more complex situations, there is quite some scaffolding that is required. We made an analysis of the required scaffolding in conceptual modeling and in particular for class diagramming. At a very basic level is everything about understanding what classes, objects and attributes are. And only when you master this level, you can start thinking about associations, like inheritance and all the other types of associations, binary associations, ternary associations, aggregation, and so on. And only when you understand these things, you can start thinking about creating simple models and grow to creating complex models, and maybe also identify patterns. But next to all this, you also need a lot of general knowledge, like knowing about conceptual modeling quality, what syntax is, what semantics are, what pragmatics are, what tools are, and so on. So this clearly illustrates that when you deal with complex learning, Bloom's taxonomy is not enough. So this is where then the 4 components instructional design model comes in. It's an instructional design model that has an excellent fit with complex learning tasks. But despite the fact that it is a very rich model, it also allows you to start with an initial setup of a model and have a set of intuitive improvements later on. It really helps you to strengthen your teaching and to structure your improvement efforts so that you don't have to do all at once, but that you can gradually improve your course step by step. And this picture shows you what this model is about. So you find here the 4 components: the learning tasks, the part task practice, the supportive information, and the procedural information. And in the tutorial, we will review those 4 components with you. Next to the 4 components, there are also 10 steps to complex learning. And those 10 steps are designing the learning tasks, designing the supportive information, designing the procedural information, and designing the part task practice. So those 4 tasks are in line with the 4 components we have identified. There are also a few additional steps about designing assessment instruments and sequencing your learning tasks, about analyzing cognitive strategies and mental models, and about analyzing cognitive rules and prerequisite knowledge. We will not address those tasks in the tutorial. We will start with the first component. The first component is about the learning tasks. According to 4CID, each learning task should be a whole task, and you have to provide support in those tasks and sequence them in the correct way. A whole task would be to take the domain of cooking, for example, to make a cake, like this one. Tasks are represented in the 4CID model as a circle. Now, obviously, making a cake like this for someone who has never baked cakes would be too difficult. So the idea is that for every task you can offer a certain level of support. And in the case of this cake, the first time you maybe will just watch how your teacher does it, and then your teacher will allow you at the end to put the berries on top of the cake. So in that case, you have a lot of support, which is represented by a filled circle. And then gradually you will be allowed to do more yourself. So for example, you will be allowed to bake the chocolate dough. And so then you have halfway support. And then later on you can also make the buttercream. And in the end, you can make the cake almost completely yourself. So you have decreasing support for making the tasks. That's one of the basic ideas of 4CID. Another important aspect of 4CID is that the whole task should be varying. You should offer a lot of them to your students, and also of different difficulty levels. So we will not start with baking a cake, but we will start with more simple things like making soup or tacos. And then gradually we will move on to a bit more difficult tasks like making cookies and apple crumble, to end with the very complex cakes like these 2 types of fancy cakes. Every time we have a task, the same task can be offered with different support levels. The second component of 4CID is about supportive information. Supportive information is always available to learner and takes the form of books, video, lectures, online materials, and so on. And typically we will organize it per task class. So for example, material about requirements analysis, materials about class diagramming, structural modeling, materials about behavioral modeling, and so on. And in this supportive information, we can to a certain level also address cognitive strategies for our students, for example by giving them worked examples and tell them how they can improve their work. A third and very important component of the 4CID model is part task practice. Part task practice is helping your students to master certain mechanical skills. So for example, how to use a modeling tool, or to have a very small task like how to create an association between two classes. And you can implement that, for example, by means of online quizzes. And then the last component is procedural or just-in-time information. So this is information that is not always available to your student, but that you give to your student when they need it. So this can be online feedback in online exercises. This can be hints in a tool or in exercises. This can be, for example, simulation of models. And then we will conclude the tutorial with lessons learned. When you apply this model, does it have an effect on students' learning? What is the effect on your workload as a teacher for developing your course material? And what is the effect on grading? Does it help you with grading? Does it make it more difficult? And so on. And then, of course, during the tutorial, we will make sure to provide you with lots of examples from our own course material. And then finally, we will make sure that both during the tutorial and at the end, we will give you enough time for asking questions. We will make all material available to you through this website, and we will also provide you with the necessary references. Hope to see you on June the 10th, and in the meantime, stay safe.